Today we are solving trig equations. So we're still going to look for the angle. We're trying to solve for the angle. However, we aren't using sine inverse or arc sine. We're not using the inverse trig functions in this problem. So for the inverse trig functions, your domain range were restricted. Remember, for like arc sine for sine inverse, it's positive in the first quadrant, negative in the fourth quadrant. We're not using those today, so we're not restricting our domain range. We are going to put our triangles in all the quadrants necessary. We're not restricted. So when you're solving a trig equation like 2 sine of x plus 1, you want to isolate your trig function. So first thing that's got to go is 1. I'm going to subtract 1 from both sides and then divide by 2. So again, I'm not using the inverse trig function here. This is just sine of x. And so I need to think, which quadrants is sine negative in? Sine is negative in the third and the fourth quadrant. So I'm going to have 2 triangles for this problem because I'm not restricting my domain range. So sine is opposite over hypotenuse. And that would make the adjacent side negative root 3 over here and positive root 3 over here, making this 30 degrees and this 30 degrees. And radians, this angle would be 7 pi over 6, and this angle would be 11 pi over 6. So 2 answers, 7 pi over 6 and 11 pi over 6. I'm not using the inverse trig function, so I'm not restricting my domain range. Next one, 3 secant squared x minus 4 equals 0. All right, so first thing I need to do is move the 4. Then divide by 3. And I have secant squared x. I just want secant x. So I'm going to just take the square root. When you take the square root, you need to do plus or minus the square root of 4 over the square root of 3, which is secant x is plus or minus 2 over root 3. So what that means is I'm going to draw triangles where secant is positive and triangles where secant is negative, since it's plus or minus. AKA, I'm going to have a triangle in every quadrant. Secant is hypotenuse over adjacent. And this one, hypotenuse over adjacent. Adjacent. And oops, that's just a 1. Anyone. Alright, so that would make this angle 30. So in radians, this angle would be pi over 6. This angle would be 5 pi over 6. This angle would be 7 pi over 6. And then our last angle is 11 pi over 6. So there's actually 4 answers that work because it's plus or minus. So you're going to have a triangle in every quadrant. Alright, the next type of problem would be something like this. Cosine squared x minus cosine x equals 0. So I see that both of these terms have a cosine x as one of their factors. So I can factor out a cosine x from both of these terms. We can get cosine x times cosine x minus 1 equals 0. So I factored that. And so what I can do is then set both of those factors equal to 0. So cosine x equals 0 and cosine x minus 1 has to be equal to 0. So I'm going to solve both of those equations individually. So first one, cosine x equals 0. Where is cosine equal to 0? Well, cosine is equal to 0 up here at pi over 2 and down here at 3 pi over 2. Sorry, that's a positive 3 pi over 2. I don't know why I wrote a negative. So cosine is equal to 0 up here at pi over 2 and down here at 3 pi over 2. Second equation, cosine x minus 1 equals 0. I would add 1 to both sides. And now we need to think, where is cosine equal to 0? Well, at 0 it's equal, where is cosine x equal to 1? At 0 it's equal to 1. At pi it's equal to negative 1. So cosine is equal to 1 when x is 0. So we have 3 answers: pi over 2, 3 pi over 2, and 0.